Here is the project. greenpowerlabs leads this one. They are performing predictive energy management, which means instead of serving the current consumption, they're predicting into the future, using energy in a wiser way. The solar system provider for this project is Solar Global Solutions. It is a company just 5 minutes drive from where I live. The PV system at Emera we paid a visit last time was their achievement.
Yeah, so we're going to cover off the Smart Building Microgrid project, which we're in the process of deploying at the Technology Innovation Center in Woodside, as Michael mentioned. So a bit of a background. So the Nova Scotia Department of Energy and Innova Corp created the Smart Energy Innovation Program, and then with additional support from Carbon Capture and Storage Nova Scotia, greenpowerlabs along with Solar Global Solutions were able to be awarded the Advanced Distribution Commercial Microgrid Demonstration at the TIC building. So some of the project drivers that we're looking for here. So our objective is to enable the optimization of energy flow based on predictions of solar generation and building energy usage. The intent is to show how commercial buildings with microgrids can be leveraged as a DER for utilities, provide additional value for the utility and the building. Our goal outcome of the ADCM project is to prove the commercial viability of the predictive energy management system. So what is PEMS? So predictive energy management is optimizing the commercial microgrid for the building with PV storage and optimizing the HVAC load of that building. So what we're going to do now is just cover off kind of a high-level architecture of the system and the components, and then we'll cover off each component separately and talk about some of the technology features within that. So in terms of PEMS, what we're doing is we're taking two existing applications that we've already developed over the last number of years, one being predictive building control, which is optimizing the HVAC usage of a building by using artificial intelligence, weather forecast, and real-time observations from the building to lower the energy usage of that. And also the other application is a commercial microgrid controller. So PGC is kind of what we'll refer to it as, and that's using kind of state-of-the-art microgrid control, and then with greenpowerlabs leveraging the HMI platform and developing some advanced functionalities around that. So what PEMS will do is PEMS will be kind of the middle player here. It will take the competing priorities from each system and look to kind of levelize and see what is the best output for the system. So as I mentioned, so what PEMS is doing is looking at developing those advanced functions. So in terms of PBC, it's looking at energy optimization, occupancy, comfort, and demand management. On the PGC side, it's looking at generation control for both solar and storage, looking at economic dispatch and peak shaving by utilizing that storage. And all of this will be viewable and accessible through our EMIS platform, which is another application that we're in the process of developing. So as I mentioned, this is a demonstration project. We're in the process of deploying the hardware, but we're able to actually show some PBC performance. So when the project was awarded a couple of years ago, we were then able to deploy PBC at the TIC building. So here we're actually able to look at the energy that was saved over the last year. So we're able to save 107,000 kilowatt hours, which is equivalent to about 157 tons of CO2. So what I'll also note here is that this is only about 19,000 square foot of about 45,000 square foot of the building. So we're just best-in-class microgrid control device in those HMI platforms. So looking at the core functions, we're using the default applications that's built into the controller, so voltage, power, and reactive power control. And greenpowerlabs is looking at developing the supervisory control overlay application, so looking at power curtailment, rate of change, ramp control, and generation off and on. The way that we're doing that is we're using load forecasting technology that we've developed for the building level. as well as solar forecasting from our solar to data forecasting application, which has been in operation since about 2012. So then looking at the PEMS application here, so looking at that advanced functionality as I mentioned, so looking at microgrid and PBC advanced functionality, and what we're doing here is we're looking at real-time energy management by combining predictive and reactive controls based on forecasts and near real-time site observations. One of the key features is also that the PEMS application is able to interface with SCADA systems from utilities and accept signals to shed or provide generation to the grid, as well as provide additional visibility of microgrids. And as I mentioned too, is that EMIS application is another feature of PEMS. So here I'll ask Sean to come up and just kind of talk about the hardware that's being installed at TIC, as well as some of the operating modes.
Sure. All right, thanks very much, Chad. So I apologize to anyone who's in the room on the last presentation, but kind of the quick overview again. I'm Sean Fleming from Solar Global Solutions. So we're one of the renewable energy companies here in Halifax, primarily involved in solar, battery storage, and combined heat and power, natural gas fired CHP. And on this project, we're building the microgrid system that greenpowerlabs is implementing their advanced controls on. So really simple diagram on how this system works. There's a PV array, so that's producing direct current DC electricity and putting that into a solar inverter, which is converting it to AC to be used in the building. That's connected to a secure power panel. So if a NovaCorp wants to back up loads in the facility, they can be attached to this panel that's fed by both the PV array and the battery storage system. So there's a lithium-ion battery pack that's connected to a set of battery inverters, and that's brought into that secure power panel. Those battery inverters also have a pass-through that allows the battery or solar energy to pass through into the main service entrance on the building. So it's set up under a net metering system. The reality is, on a building of this size and for the size of the system here, it's never going to export, but it potentially could. And we move this thing forward. Okay. Just go back one here. Okay, so the last slide was in a grid connected mode, where you're able to feed either battery, PV power, or a combination of the two through to that main panel, serving loads in the building, or potentially to export under the net metering program. But as I mentioned, there's a secure power panel here as well. So that battery inverter is it's a grid generating inverter. So it's able to bring a signal online and allow the solar inverters to sync up to that. There's a neat feature there where there's actually frequency control from that battery inverter that allows the solar inverter to throttle its output to meet the loads on that secure power panel. So in terms of functionality, your primary source of energy that's powering loads on that secure power panel is PV. In the case that the PV system can't meet those loads, that's where the battery system steps in, and then it syncs back online once the grid's been reconnected. So in terms of some stats on the system, so it's a 15 kilowatt DC ground mounted array. So typically on commercial buildings like this, you'd see roof mounted systems, but for this facility there were some structural concerns about mounting this on the roof. So we went to a ground mounted design. You can see at the back section of the building there, in kind of the gray rectangle where the array is going to be placed. So this system is using a ballasted design, so concrete blocks to support the array racking, and that's primarily due to the site conditions. So there's a very large amount of large rocks that were put in when this building was built to level out the site. So it's made any sort of underground foundation work pretty difficult, so we're using a ballasted design for that. It's connected to an AC solar inverter, so it's an AC coupled architecture there with the solar and storage systems. Relatively small battery bank, 10 kilowatt hour lithium ion pack. It's a 48 volt pack, so it's designed to be able to use kind of conventional inverters, so not kind of the high voltage equipment that you see in some projects, and it allows us to basically use this in kind of a small demonstration setting. So I'll turn it back to Chad to talk about some of the PBC systems.
Yeah, what I thought I could cover off here in terms of the TIC building configuration is the predictive building control aspect of that. So typically with PBC integration, we look at integrating with the existing building automation systems that most commercial buildings have. However, this building being constructed in the late 80s did not have any control system implemented. So what we're able to do is deploy smart thermostats. So looking at, we deployed a number of Nest thermostats throughout the building, and our PBC application is actually able to talk to those smart thermostats. So we can optimize the heating and cooling through smart thermostats. We also had to install real-time electricity meters, so we're able to take that data and put that into our algorithm. As I mentioned, with no BAS, that means that the rooftop unit has no control device either. So what we're able to do with that is we bought a small AHU control device. We've installed that on the system, and we're actually able to control that separately as well through PBC as well. And then we're also in the process of sourcing a gas meter to deploy as well. So just to kind of wrap up, so as I mentioned, it's a demonstration project which is still underway. So the microgrid installation is scheduled to happen in May, with the PEM system being fully operational by September of this year. At that time, we would gladly welcome anyone over to come for a tour. We'll hopefully have a little information kiosk set up with some screens in that so you can see everything in real time. And then in terms of the next phase of PEMS, what we're looking for is additional buildings to deploy microgrids with the PEMS technology. And then kind of looking at that long-term product roadmap, we're looking at multiple buildings on the same feeder, so we can look at building out advanced features for feeder management to further add additional value to the utilities. And then just kind of one final thank you here to Novacorp and the Department of Energy, as well as Carbon Capture and Storage, and also a thank you to Nova Scotia Power, who as of last week signed off on everything. So the system's a full go now.
Can you go back to the slide where you were where you had the graph of the energy saved? Like,
Yeah.
when you say you're saving 100,000 kilowatt hours, is that what the PV is saving, or is that
No,
what your technology is saving based on how much it's ramping down the HVAC system and whatever?
That's the latter of that. So how much our PDC application is saving. Yeah. So what we're doing here, so in orange, we're looking at the baseline consumption. So we're able to take historical data, model that through some M&V applications, and then look at green as the total energy consumed over that. So then we're looking at, this is what the system would have consumed based on heating and cooling degree days, and then this is what was actually consumed using PBC.
Okay.
So like I said, so that's a standalone application. The Predictive Grid Controller is another standalone application. So then we're looking at how both of those systems that save energy or optimize energy flow, how they can be used together to kind of.
So I'm just, so like in the building, you say you're saving whatever it is, what percentage. So are you achieving that by like basically trimming down your air handlers, and is that, like, how are you achieving these savings on energy in the building?
Yeah, sure. So in terms of how we're saving energy, so we have kind of a couple of models that run. One is looking at an optimized morning startup process. So looking at what's happening outside, so using weather, we model that in a 3D environment of the building and the building response, how the building responds to what's happening outside as well as occupancy inside. And then we're able to say, this is the best time to start ramping on the different devices there. So we're able to do a stage ramp. That also helps to mitigate the demand charge. And then we have our operating mode as well too. So once the building becomes occupied, the thermostats are also programmed where if you don't like the temperature in the space, you can go to your thermostat and adjust it, whether it's warmer or cooler, and our application will pick that up. So we're reading and reading from the system every 15 minutes and writing every 15 minutes to there.
So when you speak to Innovacorp and explain where this technology and package of technologies fits within their globally competitive, investable, great IP, change the world criteria, what's your response? How are you doing on that?
How are we doing? So we're in the process of commercializing both PBC, so we're its early stage. That's still in the commercialization process, as well as PEMS. So as we can see here, as we're presenting in their session, you could say that it's going quite well. But in terms of like
follow
bigger,
up, are there a lot of others out there working on the same thing? How do you stack up compared to?
yeah. So that's a great question. So when you phrase it that way, yes. So there is some competition on the PBC side. There's competition on the grid side in terms of an application that's using both of those. There's very few of those. I can think of one other that's in North America. It's California based. In terms of PBC, so as I said, we're in the process of commercializing that. So our one differentiator there is that it's low cost, minimal investment up front. So we're actually able to leverage that existing BAS system, integrate on top of that. So we've had clients that had zero upfront investment, or they had to install a meter that didn't have a real-time meter. So, and then our business model with this is that it's a shared savings model. So a shared savings model,
Okay.
so we take a percentage of the energy saved. So when our clients come in and have to do a small investment of a meter, they kind of take that cost, and then we share the savings of the energy. So if we're not saving energy, we're not making money, and they're not paying for it.
I guess another question you could ask similar is, how much penetration of existing technologies in this space has happened? And I think it's pretty minimal, that the problem is still enormous and still there.
Yes, at the back.
So I was trying to hear back here. Did you say you were using smart thermostats?
Yeah, so with the TIC building in particular, we're using smart thermostats, and then in one of our other buildings, we're using another brand of smart thermostats to communicate where there's no BAS system.
Does your technology tack on behind the thermostats then? Like, isn't the thermostat essentially doing what greenpowerlabs should be doing?
No, we found that those default control algorithms in a Nest or an Ecobee don't actively control as well as what our application is doing.
Okay, so without a BAS, how is that sort of all coming together? Or is there any reason you didn't just spend an extra $60,000 and put one in?
Just an extra 60,000.
Yeah,
I think the cost, and we did look at, I forget the exact number, but we looked at deploying a BAS at the TIC building, and then we also looked at the same time, well, what if we just take time to develop a communication algorithm that works with Nest, and the cost of that was less than a third, I think, maybe a quarter of the cost. I forget the exact figure of the BAS system.
So would your system then work with other brands as well, or is it?
Yeah, so we right now we work with Nest and Ecobee thermostats,
Okay.
and then in terms of BAS, if the BAS has a API compatibility, then we're able to integrate with the BAS that way as well.
What do you see as like the scale of rollout for this? Is it mostly focused on commercial facilities? Where do you?
So, ideally, it's commercial facilities. What we're seeing in terms of PBC as a standalone. Ideally, our target building is about 100,000 square feet. But as I mentioned, this is I think 46,000, and we're controlling 19, and we're seeing pretty good energy savings. So we're looking at kind of the small, medium commercial to kind of large scale commercial. And then depending on how the result from PEMS and microgrids and storage and all that, there's also kind of an interest internally to kind of explore the residential market and see if there's something with residential storage and that. But that's a whole other thing we can talk about offline.
Other questions for our folks? If not, I just close by saying very happy after some stops and starts to see that we are now going to deploy this and it's going to be operational. It's not really for us to save money. It's really for us to offer an opportunity for companies that have the billion-dollar ideas, solutions, to demonstrate them in an environment, controlled environment with a test bed. So the smart microgrid, the smart controllers as a test bed to test other technologies, integrating into the other research and development labs here in Atlantic Canada. So with that, I'll thank you very much for your attention and have a good conference.